Hey guys, welcome back to Techness Arena, your code channel for all things tech. In today's video, we are gonna solve the standard deviation of sales data problem using Python and in different methods. In our previous video, we solved the mode of ratings problem. If you haven't watched that yet, have a look at that problem as well. For this problem, I'm gonna use multiple approaches and also explain the concepts clearly. So stay tuned till the end. Alright, let's jump right into our problem statement. We have been given the following dataset representing the number of products sold over 5 days. Our goal is to calculate the standard deviation of the number of products sold over these days. Before we jump into coding, let's understand what exactly this standard deviation is. Standard deviation is a measure of the amount of variation or dispersion in a set of values. In simple terms, it tells us how much the values in our dataset deviate from the mean or average value. A low standard deviation means the values are close to the mean, while a high standard deviation indicates the values are spread out over a wider range. This is the mathematical formula to calculate the standard deviation, where xi represents each data point in the sample, x bar is the sample mean, and n is the number of data points. Okay, let's jump into our problem and solve it now. So, first let's store the values for the 5 days into a list. Let's start with the simplest method using Python's built-in statistics module. Okay, importing the statistics module now. Here, we can simply write st.stdev and provide the sales to it. Stdev is the standard deviation. As we can see, the standard deviation of our sales data is approx 7.906. Now let's see how can we calculate the standard deviation using the Pandas library. Pandas is another powerful library in Python used for data manipulation and analysis. We'll first import Pandas and create our dataset as Pandas series. Next, we use the std method to calculate the standard deviation. And there we go. The standard deviation of our sales data is approx 7.906, which is the same value we got from our previous method. We are getting accurate results so far. Let's now calculate the standard deviation using the Numpy library. Numpy is a powerful library in Python used for numerical computations. First, we need to import Numpy as we always do. In Numpy, we have a built-in std function to calculate the standard deviation. So let's use this method and see what we get. Okay, here we are not getting the same value as we were getting in our previous methods. Instead, we are getting a value of approx 7.0711. What went wrong then? When we directly provide our sales data, this method calculates the sample standard deviation without Basel correction. It's basically dividing by n. It's assuming the data represents the entire population. To get the accurate standard deviation, we have to calculate it with the Basel correction. For that, we use degrees of freedom along with the std function. We can write it as it means we are specifying that Basel correction should be applied. It's now dividing by n-1 instead of n. It's suitable for estimating the population standard deviation from a sample. Also, we can see that now we got the value of approx 7.906, which is the same value we got earlier. So which one is more accurate and efficient? If we are working with a sample rather than the entire population, the second approach with Basel correction is more accurate. It accounts for the variability introduced by estimating parameters from a sample. And the first approach, without Basel correction, is slightly more efficient in terms of computation time, especially for large datasets. However, the difference is usually negligible unless we are dealing with massive amounts of data. And that's it. We learned how to calculate the standard deviation of sales data using 3 different methods: statistics, pandas, and numpy. Understanding standard deviation is crucial for analyzing data and identifying patterns. We'll solve more real-world data science and analytics problems in the future videos.
If you found this video informative, don't forget to hit that like button and subscribe to Techness Arena for more informative insights. And I'll see you in the next video. Until next time, keep learning and keep exploring.